Alright, so the pseudo rate law occurs when you have more than one reactant. You're going to put large amounts of all the reactants except one so you can see the effects of that one reactant. They use the pseudo rate law when we're talking about the integrated rate law. An integrated rate law expresses how the concentrations depend on time. So unlike the other rate law, which was concentration and rate, this one we're looking at one concentration and how it varies with time. The first order integrated rate law is ln of concentration. And remember the brackets are concentration. And this is our ending concentration. So how much is unaffected? K is our rate constant, T is time, and AO is our beginning concentration. Time and rate constant need to be in the same time, as in both seconds or both minutes or both hours. If you notice, that equation was in the y equals mx plus b format, and actually that should be that ln of concentration versus time should give you a straight line if it's first order. Again, that's ln of concentration versus time gives you a first order. And our slope is negative k in a first order reaction. A half-life is time it takes for 1/2 of a substance to react. So if you notice here, we start with 0.1 molarity, and we have 0.5 molarity after 100 seconds. So that's the time of one half-life, which means at 200 seconds we should have half of that, and so on. The equation for half-life of a first order reaction is that T1/2 or half-life is equal to 0.693 over the rate constant. So in this problem, it's telling us to calculate the rate constant, and they gave us the half-life. It's first order, so we know we're going to use that equation that we just saw a second ago. They gave us the half-life, 20 minutes, 0.693, and so K is going to have the units of minutes. But because it's first order, it's going to be 1 over minutes, or minutes to the -1. Okay, for the second part, it's saying how much time is required. If how much time is required, then we're going to need to use our integrated rate law, which we saw a few minutes ago. If it is 75%, since we're dealing with percent, we have 100% to start with. It's 75% complete, which means 25% is unreacted. Time is what we're looking for, and K is from part A, 0.035. Okay, so we can plug it into our equation now. That's ln of concentration equals negative KT plus ln of initial concentration. So our final concentration was 25. Plug everything in. Subtracting our ln of 100, we get that. Solving for t, we get 39.7 minutes. And again, it's minutes since our unit of K was in minutes. Alright, go ahead and pause the iPod and try this one on your own. Restart when you think you've got it. Okay, so this reaction's first order. And they gave us K. We could also tell that it was first order by just looking at the units of K. Since it's second -1, that had to tell us that it was first order. want to know how much remains after 2 minutes, and they gave us our initial amount. So we're looking for our final concentration. So that's our K that they gave us. Don't forget your negative sign because it is negative KT plus ln of concentration initial. We have to use 120 because if you notice they gave us 2 minutes, but our K is in seconds. They have to be in the same units. So I just converted minutes to seconds. Solving everything on the right hand side, we get negative 8.93, and then e to the negative 0.893 is equal to our concentration. So negative, our second ln, negative 0.893 gives you 0.409 molarity. Go ahead and try this one and then pause the iPod and restart it when you've got it. Alright, so we know that it's integrated because we have time and percentages. It tells us that it's first order. Again, even if they didn't, it's K is over days, so that's first order. We're trying to find out how long, so we're looking for time. It says 20% of the drug has remained unchanged. Or sorry, 20% of the drug has undergone change. So that leaves us 80% that is unchanged. Our negative K was given. Time is what we're looking for. Plus, because we're dealing with percent, 100 start value. Solving for T. Simplify, subtract, and then divide. T is 18.4 days, since we had days up at the top. Okay, so that's all first order. Second order is going to be 1 over concentration is equal to KT plus 1 over initial concentration. So still in that y equals mx plus b format. And so 1 over concentration versus time, if that gives us a straight line, it's second order. Notice that K is positive in this case, so slope is positive. Our half-life equation is half-life is equal to 1 over K times initial concentration. And for second order, each half-life is double the preceding one. Zero order is concentration is equal to negative KT plus initial concentration. So for this one, concentration versus time would give us a straight line if it's zero order. And again, our slope is negative, so we would have a negative slope if it was zero order. The half-life equation is half-life is equal to initial concentration over 2K. Alright, going to pull out your Kinetics integrated rate law practice, and you're going to need your graphing calculator. So these problems are going to be ones where they don't tell you the order and you're going to have to try to figure it out. In order to figure it out, you're going to need to graph. In our list 1, we're going to put time. List 2, we're going to put concentration. List 3, we're going to put ln of concentration. And L4, we're going to put 1 over concentration. Alright, so on our calculator, we need to go to Stat, and then Edit. And notice I have things in my lists already, so if you arrow up and push clear and enter, then it's going to clear those lists for you, instead of deleting each individual item. So in L1, like I said, I'm going to be plugging in my time, so I'm going to plug all your time values in L1, double check your values to make sure that you did put the correct numbers in. So notice I had an extra 0 on that one, so I'm going to have to go back up. So that's going to affect your answer, so make sure that you put decimals where you're supposed to and don't put too many or too few zeros. Alright, now I'm going to arrow over L2 and plug in all of my concentrations. Okay, once you've done that, then go to second stat plot, or second y equals. Plot 1, turn it on, and arrow over to get the line. And then make sure that X list is L1 and your Y is L2. So we're going to have time on the X and concentration on the Y. Then hit zoom 9. You can arrow over, but it's much easier if you just push zoom 9. And that's going to be the stat zoom, so it's going to zoom into your data. Does that look like a straight line? Nope. So we're going to have to push stat, go up to L3, and if you highlight L3, then you can push ln of L2. So we're going to push ln, and then second 2, which is L2. Push enter, and it auto-populates that column. And we're going to go ahead and populate L4 as well. We said we were going to put 1 over L2, which is our concentration. And now we're going to graph those. So again, second y equals. We can go ahead and use that plot 1 again. Just change the list. We still want time on the X, but we're going to change Y to ln of concentration. So we need to arrow over, and we need to put our second 3. Again, zoom 9. And that looks pretty straight. But we should always plot all of them just to make sure. So again, I'm going to arrow over or down and change that to L1 versus L4. Zoom 9. And definitely not second order. So looking at all three graphs, we can clearly state that this is a first order reaction. So using the values that I said earlier on your L1s through L4, L1 versus L2, if that gives you a straight line, then it should be zero order. If L1 versus L3 gives you a straight line, it's first order. And L1 versus L4 gives you a straight line, then it should be second order, based on what we put in our L1s through L4. So it says determine the rate law. All you have to do is graph it and then write your rate law. Rate equals K, concentration of what was given. And if you look at your column of concentration, it's all H2O2. So that's where that compound came from. First order, because again, L1 versus L3 was straight. Okay, if we're determining the integrated rate law, we just have to realize that it's first order. So, first order integrated is concentration, or ln of our concentration, in this case, hydrogen peroxide, is equal to negative KT plus ln of initial hydrogen peroxide concentration. To calculate the value of the rate constant, we need to find the slope. Because remember, in first order, slope is equal to negative K. So you can have the calculator calculate the slope for you by going to stat, calculate 4, which is linear regression, and then plugging in the stat lists that were used for that slope, L1 and L3. Or you can do it the old-fashioned way, rise over run, so your y values over your x values. But be careful, because your slope, you're having to take the slope of the straight line. So our y values were actually ln of concentration, not concentration. So I'm going to look at my data table and take ln of 0.505, and that's 3, or actually negative 3, and then ln of 1, which was 0, over my times that corresponded to that 36 minus 0. And so I get my K, or at least that's my negative K. And that should actually be ln of 1, not 0. So just drop the negative sign, and that's your K value. So again, you can have the calculator run it, or you can do the math. Either way. Don't forget your units. It's first order, so it's got to be 1 over seconds. Okay, go ahead and look at D. They're talking about concentration and time, so we're going to have to use B, that integrated rate law, to calculate the concentration. So we're looking for the ending concentration. We know K because we just solved for it in C. Remember, it's got to be negative KT, so that's why I put the negative sign back on it. 4,000 seconds. And at the start of the reaction, if you look at your data table, we started with the concentration of 1. So that's why it's ln of 1 there. Solving for concentration, you get 0.0357 molarity. All right, let's look at the second one. Okay, again, same thing. We're going to graph those, so we're going to go to Stat. Edit. My lists, I'm going to need to clear them. So up, clear, enter. Make sure you clear them all out. And I'm going to stick with my L1 being time, L2 being concentration, L3 being ln of concentration, and L4 being 1 over concentration. If you stick with those always being the same thing, you don't have to worry about, oh, where did I have time in this case? Where did I have concentration? Because it's always the same. So go ahead and plug those values in. So that's my time. Arrow over it. I put my concentration in. Then L3 is going to be ln of concentration. L4, 1 over concentration. Go to my stat plot, turn it on. I'm going to do L1 versus L2 first. Having some technical difficulty here. And finally, zoom 9. Okay, not zero order. So L1 versus L3 now. Zoom 9. Maybe first order. It looks pretty close. L1 versus L4. Always look at all of them. Zoom 9. Also possibly second order. That also looks pretty straight. So let's look at them again. So that's first order. That's second order. Second order is straighter. And so second order must be the rate. So our rate is equal to K NO2 squared. And again, we're getting NO2 because that was from our data table. It's second order, so second order integrated is 1 over concentration. It's equal to KT plus 1 over initial concentration. Value of the rate constant, I just plug this one into the calculator to give me the slope. And so slope is equal to 2.098 times 10 to the negative fourth. And in this case, my slope is K, so I don't have to change the sign. But I do need units, and so that's liters over moles times seconds. Alright, and then the last one on the bottom, clear some room. Going to need to use that integrated again. So I have 1 over concentration. equal to 2.098 times 10 to the negative fourth, because that's my K, times time, which is 2.7 times 10 to the fourth seconds. Plus 1 over 0.5. Again, we got the 0.5 from the data table. Look at the initial concentration. So 1 over concentration is 7.66, so concentration must equal 0.13 molarity. And that is all.